Alright, hi everybody. I just want to start off with kind of an aside. So I was kind of like wondering why for the longest time they call it a quadratic equation, because quad, you think of fours, right? So where does this 4 come in? And you don't really see, really much like any 4s in the quadratic equation, but we do see a lot of x squared. Okay, so where does quadratic equation relate to x squares? Well, the second you have a quadrilateral, when I was looking into it in the early 13th century, they were calling all squares quadrilaterals. So that's how they came up with quadratic equation, because it was a squared equation, because it was a square. So anytime you see a squared, that becomes a quadratic equation. Yeah, this is kind of as an aside. So as your Chan Academy questions, the first question I want you to answer is quadratic equation, where does it come from? Well, I'll answer that for you right now. The quadratic equation is any sort of x squared. Okay, any sort of x squared is a quadratic because it's something squared. The square is a quadrilateral. Quadratic, something squared. Okay, and then for B, I want you to tell me what the vertex is and how did it shift. So in other words, how does the h and the k change this from the parent function of x squared? So how does it change it? And then what's the shift? So what does the a do? And then how did you get the vertex from the shift? Alright, so I went ahead and placed our quadratic equation in vertex form. That's y is equal to a parentheses x minus h squared plus k. Okay, I'm going to go ahead and add the slider for everything. I want this to be 0, this to be 1, and I want this to be 0. Alright, so normally we start off with something like y equals x squared, and that's the same thing as 1 parentheses x plus 0 squared plus 0, because x plus 0, that's still just x squared times 1, that's still x squared plus 0, same thing, right? Alright, so let's check to see what happens if we move things around. So if we move our h to be a positive number, I don't like the way that's. Alright, let's go like this. Alright, so whenever we have a positive number, we move to the left. Whenever we have a negative number, we move to the left. Whenever we change the k, we move up and down. Right. So if I wanted to move down, I just keep moving down. If I want to move up, I move up. Alright, now what does the a do? If I move the a and I make it bigger, it's going to get taller. Right? I get taller. Some people like to call it getting skinnier, but it just moves up faster. As I make it less than 1, it becomes wider. If it becomes 0, well, anything times 0 is just going to get stuck there. If I go into the negatives, right now it's wide because it's less than 1, but greater than 0. Okay, greater than negative 1, but greater than 0. And as you approach just negative 1, you'll see that you have a reflection, right? The exact same thing, just on the other side. And then you can go ahead and make it even thinner, on and on. So what if I did this? What if I move this k up? See, I can move up and down. What if I made this k1 and then I moved it, let's go to the right, so I have to do a negative 1. That's how you would do that. Now when we zoom in here, we can look at how this would play out. So if we move over 1, we would have to have 1 squared. That would be 1 squared, that's just 1. If I move over 2, that would have to be 2 squared, so that would be 4. Now, why is it going downwards? Because once I do this 1 and then 1 squared, well, instead of going up, I go down because it's negative. Okay. So let's take a pause and let's come up with a good example. Alright, so I start off with our most basic quadratic equation. So I have a vertex of 0, 0 because there's no like h and there's no k. So 0, 0. So now I know that if I move over 1, then I'm going to get 1 squared, which is 1. Right? And then I move over 2, I'm going to get 2 squared, which is 4. So it's over 2, and I get up 4. Now, in this red one, what I did was I shifted it. I did a plus 1 here. So to do that plus 1, that tells me I moved 1 to the left. And then because I added a plus 1 right here, and I moved up 1. Alright, so now that I have this a of negative 1, I'm going to go 1 to the right and to the left. What's 1 squared? It's 1. So I would go up 1. But instead of going up 1, this negative 1 tells me to go down 1. If I went 2, it would have been up 4. Instead, I'm going down 4 to right there at negative 3. So watch, if I make this a plus 1, it's going to be like that. But as I make it a negative 1, it flips it. Up 1, positive 1, negative 1. Positive 1, negative 1. Now let's try 2. If I do 2, it takes all the values. So instead of going over 1 and then up 1, it'd be over 1 and then up 2, because it'd be 2 times that number. If I did 3, it'd be over 1 and then up 3. And then for going over 2, instead of 4, it would be going up by 12. Alright, so let's look at a table value, and I'll put it in paint. Let me just clear all of this. Alright, so here's an example. I have y is equal to 1/2 parentheses x plus 1 parentheses squared minus 1. So I want you to come up with the vertex. Okay, so this vertex would be 1 to the left and then 1 down. So that would put me at negative 1, negative 1. So that's my vertex. Right. So let's plot some points and see what happens. Well, why don't we plot the vertex first? If I plot the vertex first, it's going to give me negative 1 for the x. Well, negative 1 plus 1 is 0. 0 squared is still 0. 0 times a half is still 0. 0 minus 1 is negative 1. Okay, now let's try 0. 0 plus 1 is 1. 1 squared is 1. 1 times a half is a half. Half minus 1 is negative half. Okay. Now, if I go over here to negative 2, I'll plug in negative 2. Negative 2 plus 1 is negative 1. Negative 1 squared is just positive 1. Positive 1 times half gives me half minus 1. That'll also give me negative a half. And let's go ahead and try this. 1 and negative 3. If I plug in 1, 1 plus 1 is 2. 2 squared is 4. 4 times a half is 2. 2 minus 1 is 1. And what do you think this one would be? 1. So let's pull up Desmos. And we started off with y equals x squared, right? And you can think of it in two different ways. You can either think of it as translations or you can do the charts. We like translations because it keeps it more simpler. You can't make mistakes. But I just did the t-chart right there, so just in case you like the t-chart, you can do the t-chart. So y equals x squared is your original, and what we want is y is equal to 1/2 parentheses x minus, x plus 1 squared minus 1. Okay. So what did we say about the vertex? The vertex was -1, -1. So yeah, that's right there. And the way you thought about it was that when you move over 1, what's 1 squared? It would have moved you up 1. But because you have the 1/2 in front, it takes that value to half. Alright, now if we moved over 2, right, we would have gone up 4 in a normal one. Okay, if this was 1, we would have had, yeah, I'll go ahead and put it, y equals 1 x plus 1 squared minus 1. Alright, we would normally have over 2, and then 2 squared is 4. Right, that would put us at here. So we go over 2, up 4. And that point would be 1, 3. Instead, since we had that half in front, we have to go over 2, and normally instead of going up 4, we now only went halfway up. So what's half of 4? 2. So it would be at 1, 1. Okay, so that's the idea behind it. Notice that it's always like perfectly symmetrical. If you go over 2 this way, normally you would have went up 4, and that would have put us at -3, 3. And then instead we had half of that amount, and that would put us at -3, 1. See how it's half. Okay. Now let's talk about the domain here and the range of just this one. Alright, so the domain, no matter to the left or right, you can always see that it continues. So the domain for this one is -infinity, +infinity. And I'll just put that right here, -infinity, +infinity. That's the domain. Alright, that's the domain. Now, as far as the range goes, now what's the lowest thing we can get? The lowest thing we can get is y equals -1, because it actually hits it, right? Right there, it hits it. So now, instead of parentheses, it should be a bracket. And I can't seem to do a bracket in this, so I'll do this. Bracket, and it should be 1 is the lowest point you can get. Sorry, -1 is the lowest point you can get, and then you can keep going up, +infinity. So this domain would be -infinity, +infinity, and those are in parentheses because you can't touch them. Now the range, since it does touch -1, would be a bracket, -1, +infinity. Alright, so before we end this video, let's see what it would look like if you had one that was pointing the other direction. So if I had -1 of that, what would the range be for this? Well, the domain is still the same, -infinity, +infinity. The range would change because it would become the lowest point, -infinity. What's the highest point? -1. Alright, so in this case it would be backwards. It would be -infinity is the lowest, and the greatest you could get would be -1 and then bracket. Alright, so send me an email if you guys are a little confused. I know it's a lengthy video, but hopefully it just really covers the fundamentals. So just try and keep us all together. Alright, see you guys in class.